So as part of this, we will look in detail what Amazon Web Services is. These are the high-level steps. You have to create an AWS account. I will not go through the steps to create an AWS account. Typically, you just go to website. Okay, you will go to aws.amazon.com website. And then if you are already an Amazon customer, it supports single sign-on, so you need not do much. You can just click on sign into the console or get onto my account and click on AWS Management Console, and it will ask for your username and password. And you have to use the username and password. Once you log in, if you are first time, it might ask you for some details. And then you have to enable your credit card and all those things to be charged by these guys. So it's a standard process which you need to follow to get to this page. Okay, I will not be covering each and every step to get to this page, but it's just a typical way of setting up your account with any vendor. You have to give the credit card information so that they can charge you for the nodes. Which we will use. Okay, and then as part of understanding AWS, there are multiple things which you need to be aware of. One is regions. So region AWS is a globally distributed. AWS means Amazon Web Services have globally distributed data centers, and each data center or each region will have a bunch of data centers. So make sure when you actually provision the nodes, you use one region always. So if you go to the right-hand corner on this Amazon Web Services console, you will see like this on the right-hand corner. By default, it is Northern Virginia. For me, for some people, it might be something else. So you have to choose your region before you want to start provisioning the nodes. So in my case, I have chosen Northern Virginia itself. So everything that I will provision in AWS will be in Northern Virginia itself. Okay, that is the first thing which you need to be aware of. And then key pairs. Key pairs is like if you are familiar with SSH, you will understand pretty easily. If not, also that is fine. You will understand what SSH is later. But for now, I will just try to explain what it is actually. So when you actually provision the nodes, you have to select a key pair, a new key pair or existing key pair. So let me show you that. Okay, I'm just trying to provision a node. So it will look like this let me go back. I will explain. So this is the home page once you get into AWS Management Console. So it has many things in this, but for our purpose, we are more interested in EC2. EC2 means it's getting servers which are pre-configured for your purposes. Typically, we will get a Red Hat server or some other Linux server, but there are many such things which you will see soon. Similarly, there are many other services which AWS provides. So if you are interested, you can explore these things. But for our session, we will be most likely working with EC2 and VPC. VPC is for networking. Okay, you will understand what VPC is later. But for now, I want to explain what key pair is. So, okay. Sorry for the noise. Okay. So for this entire course, we will be just focusing on EC2 and VPC. Nothing else will be touched in this. Okay, so I'm talking about EC2 and I'm primarily talking about key pairs. So once you click on EC2, there are a bunch of stuff. So what are these? So let me explain you by doing a whiteboard real quick. So typically, if you want to build a cluster of multiple nodes, whether it is Hadoop or RHEL or anything, what you want to have is storage. You will have a storage. So this is storage, and you need to get bunch of CPUs, and you need to have a network. Okay, and all of these things will be connected to network. Okay, and once you provision the servers, you don't want everyone to log into your nodes. You want to control. You want to give controlled access to the outside public. Okay, if someone want to use their computer and connect to your cluster, you want to control them that they cannot access everything on your cluster. So for that, typically organizations, so all these nodes will be connected to another network switch. So this is a network switch. This is a network switch. These are actual servers. And for that network switch, they might enable the firewall, and you have to open certain ports for common public to interact with your cluster. Okay, let me talk with Jay. Yes, Jay, go ahead. You can unmute yourself and you can talk. I think it was a mistake. Okay, so you have to open ports for your cluster. So where will you open the ports in your cluster? It will be in the firewall. So if you go back to AWS now, on the left-hand side, if you see, they have categorized most of the stuff into the, different categories. One is the instances, the other one is images, and then Elastic Block Store is for storage. So we are talking about all the things which I have shown in the whiteboard. So this is the storage, and if you want to deal with storage, you have to go to Elastic Block Store here, and you can add storage. Yeah, cluster is nothing but a bunch of nodes, and making them work together for a common purpose is called a cluster. You will understand. I mean, even if it is not very clear at this time, by the end of the session, you will understand what a cluster is. Okay. So again, node means any server. It could be physical or it could be virtual. So Elastic Block Store is for storage. And then we have spoken about network switches, so and also the security related to firewalls. So here there is a category called network and security, and there are a bunch of things that are related to networking, which we will understand later. And security groups is for firewall, and Elastic IPs, key pairs, all these things are for network. We will be interested only with security groups, Elastic IPs, and key pairs. And at this time, we are talking about key pairs. So they are under the category of network and security. So you can click on that. And I have already created a key pair for my purpose. So before even provisioning the cluster, you can create a key pair for yourself also. And you can use it for all your clusters. Let me unmute, I think, someone. It is making noise. I think
Hey Durga, are you talking?
Yeah, I have unmuted. I'm sorry. I don't know. For some reason, are you guys hearing the noise, or it's only me who is hearing the noise?
I'm not hearing any voice.
Hey, Durga, we are fine, Durga. We're not hearing any noise.
Okay.
We're just hearing your voice. Yeah.
Okay. Yeah, now it is better. So let me start a instance real quick, and I will try to explain the significance of that key pair. Key pairs are mainly for the passwordless login between your PC and the nodes in the AWS cluster. So we will see that in a moment. And then there is a concept called VPC. So even before provisioning the nodes, you have to create the key pair, like what I have shown now. I will show the significance of it in a moment. VPC, so when you actually provision the nodes, you will see information like this. So there are a bunch of private IPs and there are a bunch of public IPs. So this is public IP and this is private IP. Okay. If you don't use VPC, it will take EC2 Classic for your networking. Okay. You don't need to understand what is EC2 Classic in detail. What you need to keep in mind is if you use the default, which is EC2 Classic, your IP addresses will be changing. So as I mentioned to you in the picture, if public want to interact with your cluster in a typical setup, they will use public IPs. Okay, so it will be a public IP here. So this guy will enter the public IP. In this case, the public IPs are on the right side. So this is the public IP, and this is the public DNS, which is alias to this public IP. So in this case, any one of you can actually use this public IP, which is 54, 84, 195, 141. Okay, if you already have Pigwin and all, you can actually ping using this IP, which is 54, 84, 195, 141, because I just started it. So public can interact with this cluster using this public IP, and then to interact with these to interact among these servers, if they also use the public IP, and then the network usage will be very high. Typically, it will be very expensive for the organizations. I will not get into a lot of details over there, but keep in mind that you never configure the communication between your clusters using public IP. You have to use private IPs. So in any organization, typically you will see this. If you are from RHEL background or sysadmin background or any support background, you will see both kind of IPs, public IPs and private IPs. Public IPs are for external people to connect to your infrastructure, and private IPs are within the private network to interact between themselves. We use private IP. There are two advantages with that. One is you need not pay to external vendors for your IP addresses if you use private IP, and second one is performance will be much better. So to interact between those two among the nodes, we have to use private IPs. Okay. So when it comes to AWS, you have to have private IPs as well as public IPs, and even with Classic or VPC, you will get those. But when you use Classic, these IPs will keep on changing. So if they keep on changing, especially if we just want to do R&D, it will not be good. And let me explain you when they will change. So once you provision the node, if you click on actions and if you go to instance state, you see options of terminate, reboot, and stop. If you just reboot your instances, so if you are using AWS for a production system and if you keep on rebooting, you never stop the servers, the private IPs and public IPs will not change. They will stay. So for those kind of scenarios, you can go with classic and you need not worry about IPs. But for our demonstration purposes, we don't want to pay to AWS all the time. So we want to minimize the usage of our systems. So we want to stop them and start them whenever we want. If we just use EC2 Classic for our networking, these public IPs and private IPs will be changing all the time. Okay. So to make the private IP static, what you have to do is you have to use VPC. That's where the VPC will come into picture. VPC stands for Virtual Private Cloud, and even you can make your public IP static. I will explain it later. But now the topic is VPC, so let me explain what VPC is. The purpose of VPC is to actually get the static private IPs, so that if you stop and start your nodes in the cluster, the IP addresses will not change and your applications which are deployed on the cluster will not have any impact. Even if you do not follow it completely now, it is fine. You will understand these things actually when we start deploying Hadoop. And then if you once we complete the session, if you review this video, it will start making a lot more sense. So even if you don't follow at this time, that is okay. Okay. So how you want to use how you want to create the VPC? Either you can go to home and then click on VPC, or from any page you can click on services and you can see VPC here. So you can click on VPC and then you can click on Start VPC Wizard. You can click on Select, and for that you need not worry about most of these things. You can just use the default ones and you can click on Create VPC. Okay, and then you can click on OK, and then you will see this. And then you will start using it for your purpose. So it is pretty straightforward to create it. The only complex is you should understand the purpose of it, and then you should start using it when you start building the cluster. Okay, so for now, that is it about VPC. I am deleting this. I just created for the demo purpose. I will be using my original VPC for our cluster. And then we will talk about Elastic IP. As I mentioned to you, there are public IPs for using which common public will start connecting to your cluster. And if I use EC2 Classic or even VPC, if I use the default IP addresses that are assigned to the cluster, and then again they will be changing whenever you stop and start the server. So if you do not make Elastic IP static, only side effect is you have to change the IP addresses all the time to connect to the cluster. But using VPC, you can deploy your applications and they will be up and running all the time. Even if you stop and start, there will not be any impact for your applications, because when you actually install it, no, it's a very good question. VPC is one for the entire cluster. So in my case, if you see, I have 8 nodes at this time, and all of them are using the same VPC. So here, if you see, it is giving the VPC ID. You can click on any of these nodes, and the VPC ID is same. Okay. And yeah, also get familiar with this interface. You can add and remove the components whenever you want. So you just click on Settings, and if you want to see the VPC ID for all the nodes without struggling with each and individual node, you just click on Settings and then add VPC ID. Yeah, VPC is the concept which you will use to get your private IPs. VPC is not IP. Private IPs will change. But if you use VPC, means private IPs will be different for each of the node. But if you use VPC, when you stop and start the nodes, for each and every node, the private IP will not change. once the IP is assigned, it will stay forever. Okay. So if you see the VPC ID is same, so I'm using the same virtual private cloud. So VPC, you can think of VPN. So if you are using VPN to connect to your cluster, each server will have a private IP, and those IPs will remain forever. So we are trying to replicate similar to that in AWS. So VPC is like your VPN, which means virtual private network. In this case, VPC is virtual private cloud. So you need not have to install a VPN software to connect to it, but it will make sure that the private IPs for each of the nodes will not change. So so that each one can interact with them whenever they are up and running without manipulating, without changing the IP addresses. Okay, that is about private IPs. Now we are talking about actually public IPs. So public IPs are the ones which will we use to connect. So let me show you how we can connect in this case. So you will understand this command later. No need to don't try to decipher this command and try to understand it. Just follow it for now, and then I will explain it. So this is how we typically connect to nodes in the AWS. Okay. I'm using the wrong one. So let me do this. Okay, see, I'm able to connect to it. It is. Okay, so I have given alias to that. Yeah, the reason is I didn't give the username and username actually. That's the reason why. So let me. The syntax of my previous command is not correct. I have to give the username. Now it will work. So this is how we will typically connect. And in the beginning, I spoke about key pair, right? I have used I have named it as D Gadiraju. So I am using that information to actually to connect to my nodes in the cluster without passing the password. You will understand this later. No need to worry about it. But what you need to understand is if you do not use static elastic IPs, which is used to connect, which will be used to interact with your cluster, then whenever you stop and start, these IPs will change. So if you want to connect to the same cluster again and again, you have to remember this, keep track of these things, and you have to change those things, and it can be counterproductive over time. So for that reason, even elastic IPs, you have to make it static. Okay. So when it comes to VPC, it is free. You need not to spend money to get static private IPs using VPC concept. But elastic IPs are kind of, it will be open to the public, the entire world outside AWS. So AWS, it is a little bit expensive for AWS to maintain these elastic IPs. So if you are using default IPs, then they will not charge for your public IPs. But if you want to make them elastic, then they will charge you, and the charge will be very minimal. For I think it is around $4 or $5 per month, or even less for each of the IP addresses. Okay, And the way you will deal with elastic IPs is, again, IPs is all related to network. So you should first understand when you are thinking about setting up the cluster, you should first understand which category it will fall, whether it will fall under servers, or it will fall under storage, or it will fall under network and security. Based upon that, you have to go to that category. In this case, elastic IPs belongs to network and security, and you can click on here, and then you can click on allocate new address, and you can start getting IP addresses. Once the IP address is there, you can click on that and select, and then click on associate address, and you can choose the instance to which you want to assign the elastic IP. And then you need not worry about changing your public IPs to connect to the nodes in the cluster. Okay. Again, if you cannot solve it completely, that is fine. When we actually do hands-on stuff, yeah, for now I just have one node. I have to provision 16 nodes, which I will do it once I explain the concepts of AWS, and I will even give you access. So you will do it hands-on. Whatever I'm showing you, we all together will do it hands-on, and then you will be able to digest the concepts and everything in practice. Okay. So that is about elastic IP. So both virtual private cloud and elastic IP is related to networking, and they are to keep the IP addresses static. And it is a very, very important concept you have to understand by the end of the session today. And that will save a lot of your time when you actually build your clusters and when you try to troubleshoot the issues. If you mess up with this, and if you try to build the clusters, there will be a hell lot of issues. When you try to build the clusters like this, whether it is Hadoop or any other software product, it doesn't matter. Okay, and then security groups, as I mentioned to you, is firewalls. So again, it falls under the category of security. So you have to go to network and security and click on security groups, and you can create a security group upfront. So in this case, I have created a security group called CDH5 for Cloudera. And then when it comes to, if you think about it, right, if we go back to the picture, when I'm as a person, when I try to connect to the AWS or any cluster, if you want to use firewall to control the network access to the public, then there will be inbound traffic to the cluster. Inbound means the traffic that is coming to the cluster, which example is when you run a copy command to copy some data from your local PC to one of the nodes in the cluster, it is inbound traffic. Okay, so you want to set certain rules on your inbound traffic, and at the same time, I might want to read some information from the nodes in the cluster. Okay, and then I will send a read request from my PC, and then these nodes in the cluster have to send back some information to me, and that is outbound. So you are pushing information from your cluster to the external world. So that's where this inbound and outbound comes into picture. So you have to understand these things, and based upon that, you have to set the rules. Okay. To keep it simple, I am opening up all the ports, so everything will work with these with the nodes in the cluster. For inbound and outbound, I opened up everything. But in a typical production environment, whether you use AWS or non-AWS systems, you need to understand the firewall concept, and then you have to open up ports depending upon the firewall you are using. The syntax and semantics might differ, but the concept is same. Okay, you have to keep in mind about both inbound and outbound traffic. Typically, you will not be doing that. Your network team or SPS will take care of it. So as long as you have the concept nailed in your mind about inbound and outbound, you will be able to troubleshoot the issues, and you will be able to communicate with your SPS or network admins in better manner. So that's where this inbound and outbound comes into picture. It controls the access to the external world on the data you have in our cluster. Okay. And for simplicity purpose, I just opened up everything, and we will be using this security group for our cluster. If you start from scratch and if you want to create a security group, you just click on create security group, and then you can add rules for inbound. One thing you have to do is SSH. So you can do individual IP addresses, and the I don't know the purpose of /0, but these 4 zeros is for everyone. If you want to just limit access to a few people in it, then you have to add multiple SSH rules, and then you have to give multiple IP addresses as part of the SSH rules. And then TCP also. I mean, so if you want to use it for Hadoop, it will be better to open it for all non-standard IP addresses. I think 0 to 8,000 or something are used for standard purposes. So you can open up from 8,000 to 65,535. And when you actually configure Hadoop or any other open source or any other tool, you have to use non-standard port numbers, and you can open it up for them. So you have to understand the purpose of these 3 things. I will not be covering in detail SSH, TCP, and ICMP. You should understand them, and then you should be able to negotiate with your SAs and network admins to open the ports in a proper fashion for both inbound and outbound. Okay, that is about security groups. Again, you might not be dealing when it comes to deploying in our production clusters. You will not be dealing with virtual private cloud, elastic IP, and firewalls by yourself. You have to work with your SAS and network teams, and unless you have the concepts in mind, you can provide incorrect information to them, and it can cause some issues. And also, if you are from Oracle background, Oracle DBA background, the role of Oracle DBA is completely different from Linux. You just need to create a checklist to your SAS and network team, and they will give you whatever you want. But when it comes to Hadoop, you will be dealing with smaller to medium-sized clusters, and they will give you the root access, especially when you are building the POCs, when you are building clusters for POCs, and they will pass on everything to you. When I say they, network admins and the system admins, especially system admins, they will give you root access. You will be sudo into root, and you should understand all these things to troubleshoot and also to configure by yourself. So it is very important to understand these concepts, especially the VPC and the elastic IP. Firewalls, you can work with network team and get it resolved over time, but you should be familiar with virtual private cloud and elastic IPs. If you do not understand these concepts, you will make significant mistakes. And now we are talking about Elastic Compute Cloud. Okay, and before going that, I will cover AMI and storage a little bit. Then I will come back to EC2, and we will start provisioning the cluster. Okay. So let's now go to EC2 now. So the first page will look like this, and if you want to provision the nodes, you click on launch instance, and then you will see a bunch of options here. Okay. So you need to understand certain details. 1 minute, okay. You need to understand few details before you decide to start provisioning the nodes. Okay. First thing is you should understand what AMI is. AMI stands for Amazon Machine Image. So it's a typical cloud concept So you can create a machine image, which means you can carve out a virtual node, and then you can install all the softwares, whatever you want for your setup, and then you can create a template. So this AMI is nothing but a template with some predefined configurations. So for example, if you see this AMI uses Amazon Linux as OS, and then apart from OS, it also has additional software. It has Ruby, it has PHP, it has Postgres, which is a database, and it has some other tools. So depending upon what you want to do, you can decide which AMI you want to use. Okay, you can go to AWS Marketplace. This is the first. This one is quick start. It will only show up the most famous ones or the most most famous ones in the marketplace. But if you want to go for specific ones, you have to click on AWS Marketplace, and then you can search for it. For example, if you want to have AMIs for Oracle, you can do that. And there will be some AMIs which are related to Oracle. So you can provision this node, and then it will come with the Oracle. So you need not worry to install Oracle and all. Everything will come with inbuilt. Okay. And similarly, if you want to do Hadoop, or let's say Cloudera, because we are using Cloudera, I think there is nothing there for Cloudera. Let's check for Hadoop. Yeah, if you click on Hadoop, there are some specific customer-based Hadoop installations, which will come with Hadoop, on which Hadoop will be installed already, and you can use that AMI, and it will come with all the software. So it is very important to understand this. And one more thing you need to keep in mind is I am covering AWS, but there are many other cloud providers like this. There is Rackspace, there is Google, there is Microsoft Azure, there is IBM SoftLayer. So they are not as sophisticated as AWS, but the concepts are same, and they are also coming up with marketplace concept. So if you are familiar with this, irrespective of the cloud you are using, you can apply these concepts in any cloud, and you can provision the nodes with the software. And then you can focus on whatever you want to do instead of struggling from buying the servers and then installing the softwares and all those things. You can avoid all that stuff and quickly get into what you want to do as part of that practice at that time. So it is very flexible for R&D. If you want to learn any software, you can go to any of these cloud providers, and you can follow the similar concepts. Okay, so that is about AMI. AMI is nothing but a predefined template with all pre-configured software, where you can just use it to build your servers, and then you can start playing with it. And what is the other thing I need to explain? Storage. Okay, so again, I will go back to picture. We need to have servers, we need to have network, we need to have storage, and we have to deal with the security. All of these things are covered. Now we are talking about storage. Okay, and these are the typical concepts irrespective of whatever software product or technology you want to work with. You have to apply these concepts. These are most basic stuff. If you understand this, then you can build on top of it whatever you want. Okay, so again I am going to services, click on EC2, and Elastic Block Store is related to storage. And there are two things, volumes and snapshots. So what is a volume? Volume is nothing but especially when it comes to Elastic EBS, it is called as EBS. When it comes to EBS, It is kind of a network mounted storage, and you can provision as much storage as you want. And what you need to keep in mind is when you use EBS, they will charge for your storage on monthly basis. So I think for 300 GB it will be around $30 per month. So whether your nodes are up and running or not, as long as you have the volumes showing up here, whether you are using it or not, if you provision it, you have to pay for it. So you have to be very careful when you are dealing with storage. When it comes to EC2, as long as they are stopped, they will not charge you for instances, which we will see later. But when it comes to storage, they will charge monthly. So it is a fixed cost. So to limit that, you have to be very careful in determining how much storage you want to provision. You have to calculate accurate numbers, and you have to go with desired storage upfront. Because once if you fault at that, and if you want to add more storage, it is not very straightforward. And it can be done. It is not complex. At the same time, it will eat up your time. So first, understand how much storage you want to provision, and then we will do it while provisioning the node itself. But after that, if you want to add more volumes, you can come here and you can add the volumes. Then you have to do some SA stuff, system admin stuff, to reflect that storage on our nodes. Okay, I will try to demo that if time permits before the end of the course. But for now, don't worry about volumes. Just understand the concept. When we actually provision the nodes, then itself we will tell how much storage we want, and it will reflect here. And then snapshots. So snapshots are for backup of your storage. Again, when you create a snapshot, it will lock the storage. So your cost will be double or triple depending upon how many snapshots you are trying to manage. Okay, so be careful while creating snapshots. But the advantage of snapshot is you will have a backup, and there are certain scenarios where if you create snapshots, it will save some time for you. But I will not get into details. Just keep in mind that it is for backups. Okay. Now we will go to provisioning the node. First thing is you have to choose your region from the top right corner, which I showed earlier. You have to define the key pair. Again, that one also I have shown already. And then you have to configure VPC, that I have demoed you also. And then elastic IPs to have static public IP. By default, it is limited to 5. If you try to create more elastic IPs, then Amazon will not let you do that typically. But you can ask them to increase the limit, and they will increase it. So you just have to file a service request, and it will be done in 15-20 minutes. If you after filing the service request, it will give you an option to call me, where you have to give the number, and then you will get a call from Amazon, and someone will help you within 2 minutes. And after someone takes care of that, within 15 minutes, they will reflect. And again, when you raise the request, you need to tell whether you are using VPC or EC2. Okay, in our case, we will be using VPC. So keep in mind that when you ask them to increase the limit, to increase the limit for VPC.
So Durga, what is this public IP limited to 5? Let's say if I have like 6 hosts, cannot use 6 public IPs? Hello?
Okay, now, yeah. Who asked me the question? Was that Karthik?
Yeah. Yes,
Yeah.
Durga.
Yeah. So yeah, that's what I'm trying to say. If you follow me, by default the limit is 5. The reason is, as I mentioned to you, public IPs are expensive and they don't want to, and they are limited. So they don't want to just give up to anyone who want to experiment. So they want to control that. So by default they will give 5. And if you think about it, in most of the cases, 5 is more than enough. So even if you have 20 node cluster, you will typically set up, you will have 20 private IPs, and you will use those 20 private IPs to communicate with each other when you build the cluster. But to interact with that, you can have another gateway node. It is termed as gateway node, and that will be exposed to the public. And you can have some desktop software on that gateway node, and using some Windows or Linux-based desktop interface, you can get into the network using the public IP. Once you are in the network, you can actually access the entire cluster without any issues. So even though limit is 5, it is more than enough in most of the cases. But even then, if you want to increase, you have to write a service request to Amazon. And as I mentioned to you earlier, within 20 minutes you can get, you should not ask 100 in one shot. It will be tough for you to justify. You can ask them to increase to 20, and once it is increased to 20, if you want more, you can slowly increment more and more IPs depending upon the usage.
Okay.
And keep in mind that they will charge you for the elastic IPs. So the more elastic IPs you provision, and even though limit is, let's say you increase the limit to 20, you should only use as many as you want. If you use all the 20, you will end up paying like $40, $50 just for elastic IPs per month. Again, it is a fixed cost. Once you get the IP address provisioned, whether you use or not, they will charge. For example, in my case, the limit is 20. In my case, my limit is 20, and 4 of the elastic IPs I have not associated with any of the nodes at this time. And if I leave them like that throughout the month, my cost will just double, even though I'm not using them. So you have to be very careful when it comes to storage and elastic IP, because they are fixed costs and they charge monthly. And I have shown you about security groups as well. Now we will go through provisioning the EC2 nodes. Okay. So first, we have to choose the AMI based upon OS. Then we have to choose the VPC. If VPC should be pre-created, then we have to configure the storage. You can do it at the time of the provisioning the node. You have to choose the security group. Security group also, it will be better if you can predefine it and use the existing one. Otherwise, it will become unmanageable over time. Yeah, what is the time now? It's not even 1.5 hours. So we will take break around 9:45. We will provision the nodes and then we will take the break. It will take 10-15 minutes to provision 16 nodes. Okay. And then we have to choose our key pairs so that we can interact with the cluster. And then we have to launch the instance. And then we have to associate the elastic IP addresses. So I'm planning to build 16 node clusters. I have 4 elastic IPs. So first I want to increase these elastic IPs real quick. So let me do that. So when you actually want to create new elastic IPs, you just click on allocate new address and select VPC. If you use EC2, it will go to EC2 and you cannot be able to associate with your nodes if you use VPC as your networking when you provision the nodes, which you will understand momentarily. But keep in mind that in our case, we will be using only VPC. Never use EC2 when it comes to networking. Okay. So it is pretty straightforward. You cannot do it in mass. You have to click each and every one. The only thing you need to keep in mind is you should use VPC. Yeah, I also mentioned that we can increase it by raising service request. As I want to build a 16-node cluster, and I want everyone to log into these nodes as part of the lab. I make sure that I associate static elastic IPs for all the nodes. To facilitate that, I have to increase my limit to 20. Okay, now so if you just have 5, after 5 you will see this message. Now I have 4 already pre-assigned, and I have got 16 more now. Now I reach the limit. Okay, now we got all the 16 elastic IPs. Now we will be provisioning the nodes. So click on EC2. So click on this home button, and then you will see here, or you can even click on services and go to EC2. And then first let me stop the existing instance, the running instance which I have started earlier. Now I can click on launch instance. Okay, here the Cloudera. So before provisioning the nodes for your purpose, one of the practice you need to do for sure is to go through the technical specifications of the software product which you are installing. So in our case, we are installing Cloudera. Okay, so it's CDH5 installation. So whatever version you want, you can Google it, and you can click on installation and upgrade, and you have to go to the requirements. Okay, and there is another easier way, instead of searching in the documentation, to determine which version you have to provision. Okay, the other easier and most straightforward way is to go to, so each and every vendor will provide the software as part of their repositories. So if it is RHEL have its own repository where you have to register and then you can download the software. Similarly, Cloudera also provide all the software under this archive.cloudera.com, and you can say CDH, and in our case, I want to install 5. Okay, so you can click on archive.cloudera.com CDH5 and hit enter. Yeah. Okay, and in our case, we will be. You can click on any of these links. I will be looking at require starball, and you will see all the versions. If you want to go through earlier versions, there might be some links. You just have to Google it. I think you can even go to CDH. Yeah, these are all latest ones. If you want to go to CDH4, probably you have to Google it, or you can play with this link. In the CDH5, you can try CDH4 or something, and then you will be able to get it. Or you can go through the documentation. Documentation will surely give the correct information. But instead of struggling with the documentation, this is the better way, I feel. So in my case, I want to install 5.2.1. So you can click on that. And then it will show you the tarballs for each and every OS. In this case, Cloudera supports CentOS or Debian, or I think SLES is SUSE Linux Enterprise Service or something, probably SUSE, and Ubuntu. So depending upon what OS you want to use, you have to decide first. First, you have to decide the OS. Let's say you want to do it on Red Hat. So CentOS is nothing but a flavor of Red Hat Linux. CentOS or Fedora or Red Hat are same. So in this case, it says CentOS 6. So that means you can only, these things will work only with Red Hat 6 or Fedora 6. If you try to use Fedora Red Hat 7, you will run into issues. So first you need to understand, go to the technical specifications, determine which OS version you have to use. Then you have to go to your EC2, and then you have to go for the appropriate version. So in this case, I am on the quick start link. So Red Hat 6.5 is available here. If you want to, if the version is not available here, you have to go to AWS Marketplace or Community AMIs, and then you have to search for it. Let's say Red Hat 6.5. So you can see all the Red Hat versions here. So even you can provision with CentOS. I will be going with Red Hat, as Red Hat is the industry standard for Hadoop. So you will be using mostly Red Hat for provisioning your Hadoop clusters, for building your Hadoop clusters. So I will be using Red Hat, which is already in quick start. But if it is not available in quick start, the version you are looking for, you have to come to Marketplace and search for it. And then in this case, I already have here. I have to click on select. Okay. And now comes selecting the appropriate node. Okay. So you see T1.micro and it says free tier eligible. First you have to go to the specification of the cluster. Again, when it comes to a server, it is all about the CPUs, memory, and storage. Okay, those three are the more important things when you think about individual server. And this one is one virtual CPU, and it only has 600 MB RAM, and it supports EVS, which we want. We will be using EVS only. So, and it says free tier eligible, which means that they give this instance for 750 hours. So you can, if you want to just play with AWS, you can actually provision T1.micro instance and you can play with it. But it will not serve our purpose, and I don't want to go into a lot of details over here about T1.micro. So how do you want to determine the instance? The first criteria will be cost. So you have to understand what the cost is before making the choice of what type of instance you want to use. And also you have to look into the configuration details. So you have to keep configuration details and cost in mind before provisioning the cluster. For Hadoop, it will be better to go with large, but for most of the other systems, you can go with medium. Okay. CPUs and all for R&D purpose, it is not very important. Okay. But if you want to use AWS for your production systems, then you have to sit with the architects and you have to determine the necessary configuration, and you have to go with it. Okay. So now let us see the pricing. There are two things which you need to be aware of when it comes to pricing. One is EC2 pricing. You can just look at EC2 pricing, and you can click on, you can select it, you can search for it, and you will see the link. Okay, and it will give you details about your pricing. And it is, again, this is applicable to any cloud provider. It's not just AWS. You can use this with any cloud provider. The interface might be different, but the concepts are same. You will be able to get the same information in one way or the other, whatever cloud provider you are using. Okay. In our case, we are using RHEL, so you have to select RHEL to see the pricing. And if you see for large, if you want to use Red Hat Linux, it costs around 20 cents per hour. So for 16 nodes, if we start using 16 nodes in a cluster, so I have to pay $3.20 per hour as long as it is up and running. Okay. So you have to keep this in mind before provisioning your nodes. Okay. And yeah, again, between regions, there might be a little difference in the price, so you have to select the right region where you want to provision the node. In my case, I am using Northern Virginia, so I am using this. Okay. Actually, they have reduced the price. I'm seeing more.
Hey, Durga, this is Kati. The question.
Yeah, Kati, tell me.
Hey, these nodes, even though they are up or down, it's a cost.
No, they are only charged when they are so it's a floating. It is a floating. It is not a fixed cost. Only fixed cost is your storage and network.
Okay.
Okay.
Got it. Okay, got it.
So yeah. So it is using 20 cents per hour. We will use this for this session. Earlier I used to pay only 14 cents. I don't know why it is showing 20 cents, but that is fine. I will sort it out later. And then, so there are many variables here. You have to, for storage and network, you have to pay the fixed cost. And then for the servers, you have to pay the floating cost. And also data transfer. When you try to copy the data from external sources into Hadoop, then if you start copying too much of data, there might be some cost to that also. So you have to keep track of the cost, and you have to be able to estimate, right? So for that, AWS has provided something called AWS Simple Monthly Calculator. You can click on this. And yeah, again, you have to choose the region first. I am using Virginia, and you can click on Add New Row, and you have to choose whatever instance you are planning to use. In our case, we are using m3.large. Okay, and I am closing it, and I want to use 16 nodes, and it is. Yeah, I think I will use, it is saying 14 cents. Yeah, then why it is showing 20 cents earlier? I'm not sure, I have to check that. So I will try to use c3.large and close and save. So it will be $1229.76 for 16 node cluster, just to keep them up and running on monthly basis. Okay. And if the usage is only 10%, which means 3 days, then it will be $124. So the cost will differ based upon the usage of your node. So you have to estimate how much time you will be using this cluster in a given month, and based upon that you have to come up with the values. Now comes the storage. Okay. So for each node I want to provision 60 GB, let's say. So for 16 nodes, it will be around 1 terabyte. Okay. So let's say it is 1000 GB. And how many volumes? I want to have 16 volumes. Okay, and somewhere the price, yeah. Now the price is reflecting on the top. It is $922.82 because I am using 1000 GB storage. Okay, why it is showing that much? Yeah, so $800 for storage because I am provisioning 1 terabyte, which is 1000 GB. So for 10 GB, it is $1 per month. So for 1000 GB, it will be 1 minute. Something is okay. I think I made a mistake here. I just want 60 GB. No, EBS is elastic block storage. So if you go here, block store. So this is the, again, we came back to the EC2 console, and if you see my cursor, it says elastic block store. So EBS is that. Okay, and let's go back to here. Yeah. So the mistake I have made is I said 1000 GB for each volume. but I just need 60 GB per volume. So that's why the cost is very high. So if you see now, I have to pay $48 per storage for the entire month, and $124 for my CPUs if I want to use just 3 days in a month. Okay, and then you have to go with the elastic IPs. Okay, so 16, and then it will reflect immediately. It will be $229. So IPs you have to pay $58.56. So in our case, we have to cut down the cost. We should limit the usage of elastic IPs because again it's a fixed cost. So this is a very important tool which you have to go through before starting provisioning the nodes. Okay, now we will take a break, and then we will come back and we will resume. We will take a 10 minutes break. I think anyone have a question? No. We will take 10-minute break. It is 9:46 now. We will try to start at 9:56, and then we will resume, and then we will start provisioning 16 nodes, and then we will build the cluster on top of that, and then we will install Hadoop and other tools through the course. Okay, so I hope you all understand the costs involved before provisioning the cluster, and similar concepts is applicable to any cloud provider. They might not have this calculator and all, but you should be able to compute by yourself depending upon the cost. So I will try to add another slide to the presentation to list all the leading cloud providers, and then you can explore them. And most of these cloud providers give credits of $100 or $200. At this time, Microsoft Azure is giving $200 credit, so you can go to that. The concepts are same, but the technology might be different. So once you understand the concepts, you can leverage those $200, and you can actually provision some nodes for your stuff in the cloud providers. Okay. Being said that, I am going back to AWS again. Now we will actually do provision the 16-node cluster. So now we have understand that C3.large is cheaper. So when I go to EC2 pricing, let me show you. EC2 pricing, and when you click on this link, and as we are using Red Hat Enterprise Linux, and we are looking at on demand. So there is another thing which you need to be aware called reserved instances. When it comes to reserved instances, you have to pay some upfront fee. So for example, let's take the example of medium or large. Let's take the example of large actually. So if you look at this large, earlier we have seen on demand. Okay, so on demand, if you see, the price is for M3.large is 20 cents per hour for each instance. Okay, and if you go to reserved instances, and if you look at the same M3.large, there are actually here it is showing 14 cents, there it is showing 20 cents. I'm not sure why, but that is fine. So if you see here, it is on demand, it is 14 cents per hour. But if you go with reserved instances, and if you decide to use it for 1 month, you can reserve for 1 month. And if you reserve for 1 month, your monthly charge is only $73, which means much lesser than 14 cents, and you will be saving 29% if you compute 14 cents into 720 hours. It can be around $100. But in this case, you are getting only for $73 because you are reserving the instance. So you need to be aware of reserved instances also. So once you reserve them, you have to pay for it, whether you use it or not. But so when it comes to implementing production systems, you can leverage these reserve instances and you can save money. And also when you go with reserve instances, you need not pay for storage as well as networking. I will explain you how you can save for storage when you go with reserve instances and keep the cluster up and running all the time. I will explain you in a moment. And IP addresses will not change if you reserve the instances, and you should be only rebooting the servers all the time. You could not stop and start. If you stop and start, IP address might change, but if you're just rebooting, it will not. So you can save some money in that as well. Storage as well as networking, you'll save a good amount of money if you go with reserved instances, not only on the servers. But for our purpose, we will be using on-demand only. Okay, the reason why it is showing 14 cents is because it is selected Linux. Red Hat Enterprise Linux is a little bit expensive. Okay, so in my case, I will be using Red Hat Linux, and I would like to go with the C3 large because it is only 16 cents per hour. Okay, rather than M3.large. And then I will go back to my console and I will choose this C3.large, and once I decide what instances I want to provision, yeah, you can click on configure instance details, and here you can tell how many instances you want to create. In my case, I want to do 16 instances, and I want to use VPC. Okay, that's where the virtual private cloud comes into picture. If you use EC2, then your private IPs will be changing all the time whenever you stop and start the server. To avoid that, if you create VPC, it will be using static private IPs. Okay, that's the only thing which you need to be aware of, the number of 16 nodes, the number of instances, and what type of network you want to use in this screen. Once it is done, you can click on add storage, and in this case, I want to use 60 GB on each of the instance. Typically, you should have at least two, one for your root, and the other one for storage. This is not a good practice to increase the root. You should leave it as default. Let me go back and then click. Oh, it is still showing. I think default is 8 GB. You should leave it default, and then you can click on add volume. And when it comes to storage, we have to use magnetic. The reason why I'm using magnetic is a little bit cheaper compared to the other one, SSD. So that's why I'm using magnetic. Okay. And if you want to add more storage, make sure you select the EBS. If you use instance store 0 or instance store 1, then storage will be free. There is a predefined amount of storage which you will get it free. But if you use instance stores, when you terminate when you stop the node, it will not let you to stop. It will only ask you to terminate. The reason is this instance store is local to the node, and if you try to stop, Amazon will not let you do that. So for that reason, you have to use EBS so that you can stop and start whenever you want. Okay, and if you use EBS, again there will be a fixed cost which you need to keep in mind, and based upon that you have to provision the storage. Okay. So this is very important. You should use EBS. By default, this one will be, the root will be EBS, and it will be only 8 GB. But if you want to add more storage to that, you can increase it here. But that is not a good practice when it comes to setting up production systems in AWS. You should add more storage, and you should have multiple disks. You should not give one disk and add all the storage to it. You need to add more disks. Depending upon the requirements, and then you should add the storage. Okay, and once you add these disks, they will not be reflecting under the nodes directly. You have to do some prep work to mount the file system, which I will not be covering in this session. if you are from SA background, you should have already understand it. You have to update the FS tab, you have to run mkfs commands, and you have to create partitions. All those things you have to take care if you add additional volumes to your cluster. To avoid that and to save the time, I'm not going into that, but I have documented it. I will share with you, and you can go through it when you want to actually start building your cluster. So I'm closing it, and here I have increased it to 60 GB, so I will have only one mount point with 60 GB storage on all the nodes, on all the 16 nodes in the cluster, and then I want to tag the instance, okay? And I want to name it as NoviSync. So this one you will understand in a moment. It will be prefixed on all the nodes just to, so when I go to my console, I want to group my instances in a particular manner. So for that, I just want to create the prefixes, okay? And here I am adding the prefix, and I will edit this when we actually see all the nodes in the console. And then click on configure security group, and you can create a new group here, but I will highly recommend to create the security group upfront depending upon your requirements. And then you can, if you already have that, you can click on select an existing security group, click on CDH5 because that is the one I want to use, and you can review it. All the inbound traffic is open. It is not showing the outbound traffic, but even outbound traffic is open. So we are enabling the firewall for everyone. So now, as we are not using the default one, because the default for this instance is SSD, as we are not using the default one, it is just prompting you whether to change from magnetic to default or to continue with magnetic, whatever we have selected. Okay, I want to go with magnetic, so I'm clicking next. And now it will give you all the details for review, so you can review it and make sure everything is as expected. So we are using Red Hat Enterprise Linux 6.5, and we are using instance type c3.large, security group CDH5, and these are the ports that are open. And we are trying to open 16 instances, and then storage is 60 GB on each of them, and the tags, which is NoviSync, and click on launch. Okay, and now comes the key pair. We have created the key pair in the beginning of the session. Now we are selecting that. Means that this one is pre-created, but I have shown you how to create a key pair, and you will understand the purpose of it now once we start the instances. And then you can click on the launch instances. So the instances will be started, and you can click on view instances, and they are running. So actually you can filter them out, and now you can see all the NoviSync ones, okay? And then I don't want to see all this information here. I want to filter out something to better manage my cluster. So what I'm doing is I am deselecting all the things that are not required for me. I don't want the key name, I don't want the launch time, I don't want security groups, I don't want VPC ID, I just want elastic IPs, private DNS, private IP address, and there should be public DNS also somewhere. Yeah, public DNS and public IP is already selected, and yeah, this is it I want to see. Okay, so public DNS is not yet assigned, but private DNS are assigned, and I want to sort on the private DNS. So these are the IP addresses. So the 16 node starts with 15 and ends with 32. So there are 16 nodes, but probably some of the numbers might be missing here, which is fine. I just want to sort it so that I understand which node is assigned which name. So it's just for ease of maintenance. That's it. It is not required. the sorting. So once it is sorted, the first the node with minimum IP address, I am giving it as 00. So I am updating. I have given the prefix earlier. Right. Now we sync CDH 500. Okay. Actually, I should have given CDH 5 also. That is fine. CDH 501. You will understand why I am doing this once we actually start connecting to the cluster. It will save a lot of time once we start using the cluster, once every one of you start using the cluster. So now we just named them, and it is still showing as running. It will take some time as we are building the nodes. Okay. Now we want to associate elastic IPs. It will give some default IPs, but we don't want to use them. So let's go ahead and instead of waiting till they are up and running and some default public IP addresses assigned to it, I just want to go ahead and start assigning our elastic IPs which are already allocated. Okay. So here also you can sort them out so that we get all the non-assigned ones in some fashion, in some order. It may not be in ascending order, and you can click on associate address. To create these things, we click on allocate new address. Now we want to associate these things with our running nodes. So you can click on it. You can click on associate address, and you can select here. And now you can choose whatever instance you want to associate the IP address with, and then click on OK. Okay, only caveat is once it is selected as we have sorted, it has gone down and it will be selected. So first you have to deselect this to associate the next address. So now I'm associating the second instance. 00 is already done. So that tagging is very important to save time here. Otherwise you have to go back and forth to make sure which is tagged and which is not tagged to give the to associate the addresses. Like this, time will be saved on a lot of these mundane tasks if you use these features and name them appropriately. It's just a good practice. So 0 and 1 are done. Now 2. Now 3. Maybe it's 5. Next 6. Next 7. Now I am doing 9. Let me pause it until this is done. Let me pause. Thank you, Kanti. So I will paste it in the chart. You can run this command ping, and you should be able to ping it. If you guys cannot ping it, let me know. I am also tried to pinging it. I am able to ping it. You can use your DOS prompt or terminal. So if you are using Mac and if you are not familiar with terminal, you can go to Finder and then Applications. I hope whoever is on Linux already know terminal, but some of the Mac guys typically don't use terminal. So that's why I'm showing this. So you have to go to Finder. Finder is this blue and gray color smiley face on the bottom left. You can click on Applications, and then you can go to Utilities. And once you go to Utilities, you can see the terminal here. So you can drag and drop to your taskbar or menu, whatever it is, in the bottom. You can just do like this, so that it will stay forever, and you need not do this all the time. Once it is there, you can click on it, and it will come up like this, and then you can run all the Unix and Linux commands that are supported by Mac here. Mac is nothing but a Unix flavor, so most of the commands and scripts will work even in Mac. Okay. Just Control C. Yeah, whoever is pinging and don't know how to come out of it, just hit Control C, will come out of it. Okay, now we have 16 nodes clusters, and that's how you can provision the nodes in AWS. So being said that, this presentation is done. We have done everything, so I will be stopping recording for this, and then we'll go to the next presentation. Let me know if you guys have any questions.